Yeah, I'll get started. So I'm Ed. I run product marketing at Mesosphere. Prior to Mesosphere, I was at VMware for 5 years, while I ran pricing packaging for anything that included vSphere, which is a lot of stuff at VMware. And then before that, I started my career in the .com era as an engineer at Oracle. Then I realized I'm insanely curious and I want to know why I'm being told to build certain things as an engineer. So I went and worked as a consultant for 5+ years. A lot of my clients were in Wall Street and pharmaceutical. So I want to talk to you guys today about what Mesos. Do you guys know what Mesos is? No. No? Okay, fantastic. I'll walk you guys through it. Mesos. This thing's really down. Oh, I'm blocking this thing where I'm from. Alright, I will figure this out. Maybe I'll stand here. This worked a minute ago, so just give me 1 second. Alright, cool. So, Mesos is driving a fundamental shift in how the industry is doing computing. And the change behind the change is this guy right here. Right? So you guys might know who that guy is. Justin Bieber. Justin Bieber in late 2008 caused a lot of problems for Twitter because anytime Justin Bieber tweeted, 80 million real-time messages had to get sent to a lot of probably young girls who were fans of Justin Bieber. So you saw this thing called the fail whale, which was basically what Twitter showed when their service was not available. Beyond capacity. And it turned out the guy who ran engineering at Twitter, infrastructure engineering, was good friends with a guy named Ben Hyman, who was at Berkeley, who was one of the inventors of Apache Mesos, the distributed systems kernel that powers today a lot of things that you guys use, like Apple Siri, Verizon's infrastructure, and so forth. We'll get into that. But what we're seeing is a fundamental shift on how computing is being used by the masses. This is a picture from Vatican City in 2005 when they're inducting a new pope. You guys may have seen this photo. There's a phone over there, there's a phone over there. And some people looking at why is this guy taking this picture of the back of people's heads. And you fast forward a couple of years, when the new pope was getting inducted, this is what the scene was. Right? So what this shows you is there's a fundamental shift in how we all use services. And it has impact on how the enterprises work and how companies manage themselves and engage with their end users, right? So we're shifting from an era from when I began my career as an engineer, it was building systems so that a company can engage a user on the website or something like that. There was a shift in the late 2000s around big data analytics. A lot of that was largely around batch, driven by data scientists trying to figure out, hey, what happened last quarter or 2 quarters ago? And now we're shifting to a model where people want real-time, personalized services right now. Right? So there's opportunities there, but also risks. Right? So companies who are managing this well will be very successful. Companies that are not will probably not do very well. Because in each of these shifts, there's the winners and losers. Some examples of companies who are managing this well: Capital One. You guys know Capital One is a company that almost got famous giving credit to people that other companies didn't want to give credits to, and they did that by really doing smart analytics to find out what are some customers that everybody else thinks is not worthy of giving credit, but through their big data analytics, they found an opportunity. So key aspects of this are machine learning, streaming analytics. We'll talk more about that in a minute. But that's just one example. Another example is the Mayo Clinic, getting to personalized care. As we have our electronic medical records more pervasive, this will be even more impactful. And then lastly, Verizon, you guys all know the cab company, but they're getting into everything like Uber Eats. I have a 6-month-old at home, so every night, since my wife and I both work, it's either Uber Eats or DoorDash or some basically friendly company that's giving me free food, right? And then I don't know what Uber Rush is, but it looks like they're trying to get into logistics to shift things around. Why is Uber able to do this? Because they have an infrastructure and application platform that can scale right? And so if you have a new idea that comes up, they can roll it out relatively quickly and experiment. So if I step back and say, well, how does this look, right? This is a visualization from our awesome design team on how do you visualize this thing. So when I was an engineer, starting in the late 90s, we had structured data sitting right there. We had probably a big app server or a big machine, and this was an enterprise app. And it took 6 months for a new feature to get rolled out for the enterprise users. That was okay, right? That's not okay anymore, right? Because today, enterprise data growth, you guys know, is exploding. A lot of it is structured data, a lot of it is unstructured data, a lot of that is jet engine metrics coming out, just getting captured. And then the users of your modern enterprise apps are not just customers, they're not just employees, they're customers and frankly anybody else online that engages with your business. And the only way the industry has figured out how to tackle this is to move towards a distributed architecture. Because no one server is big enough to handle just the video. So this is, for me, a very big transition that we're all seeing in this space. And just as a visual example of what Twitter did, this was their monolithic Ruby on Rails app that had trouble scaling when Justin Bieber did it and gave you the fail whale. And so Twitter's problem wasn't they didn't have enough infrastructure. They had plenty of infrastructure. They had the servers sitting around not doing anything. But the production instance of the Twitter service was sitting on a big machine, right? And that machine wasn't big enough to handle all those requests. So what they did was move toward a microservices-based architecture so that each of these services can scale and make sure you're scaling only the parts that you need, not the parts that you don't. So that's the fundamental shift that they did. If we step back and say, well, what did Twitter do? Well, they moved towards what I like to call a modern app architecture. So it's an architecture where you're launching things in containers. The things that you're launching are small deployable services. So if you go to Amazon.com today, it's not like when I was an engineer, one big ASP and all the business logic was put in there. Now it's a lot of different services built by a lot of different teams, each of which can deploy when they are ready to do it. They're also responsible if it fails. So it gets to a very good virtuous cycle of making sure services are available. So that's microservices put in containers. Now, microservices oftentimes are stateless because you want to be able to spin them up and kill them as you need or don't need them. So where does the state, where does the information of your app sit? Right? So a lot of times we hear about cloud-native apps, stateless apps, and we all get really excited. But when was the last time you guys used a completely stateless app? And the only thing I can think of is Minesweeper, where it's okay to die if you restart it, doesn't remember anything. Right? But pretty much anything else you use is capturing state. It's a computer science term for just memory, if you will, of the application. So with modern application architectures, people are using, I don't like the term big data, but it is. There's these modern big data services. All right, I agree with that. So some of these include distributed databases. Some of these include analytics engines. Right? For me, when I see this, it's interesting because when I was an engineer, I led a whole development team that built a rules engine for Oracle CRM. Well, today you just want a rules engine. You go get Apache Spark or Hadoop, and you can move along a lot faster. Right? So, all right, this thing's finicky today. So I'll do a lot of walking back and forth.
Probably just using new batteries.
You might try placing that laptop on the projector.
On the projector? So it's hotter?
Yeah, it was mine. No.
All right.
You'll wipe out the SSD.
That's cool, man.
So let's talk a little bit more about
Not nice.
the modern app, and then there's also implications for how we run infrastructure. So I spent many years of my life, doing this stuff as a developer, doing this stuff as a product marketing person at VMware. Each of these shifts have been very beneficial to the industry. And x86, of course, put compute everywhere, right, in all departments within the companies. Virtualization saved people a ton of money and drove up utilization. So you didn't have a lot of servers that weren't doing it, having very low utilization. The challenge, though, is when you went to virtualization, you didn't change the operating model of the IT organization. You're still doing everything per server, except it's per logical server, right? And the reality is, as you move towards these modern app architectures, the amount of data that you're handling, the amount of speed that you need to have to roll out services quickly, you need to really think about running the data center in a very different way. I'll talk a little bit more about why that's so important. So let's talk about apps and the infrastructure. So apps, I mentioned earlier, the modern app, right? You had microservices and data services, and these are 4 common principles I'm seeing a lot of customers that we talk to, right? So open source, containers you guys heard about, microservices, and of course data services. And open source, you guys all know, you guys hear about that a lot today, it's a force multiplier, right? So you can pick up the latest rules engine or the latest distributed database or whatever. It's open source, you use it, you're good to go. In terms of the development standpoint, we'll talk more about support and all that stuff in a bit. But yeah, it allows a startup, right, to do a lot more than they otherwise could when they use open source software. Containers are great because why? They spin up very quickly, and they're a very easy way to package software, right? So a virtual machine might take anywhere from 45 seconds to a minute to launch. A container can come up almost instantaneously. And for that reason, they're very good for spinning up services on demand. Another key aspect of this is, it's funny, virtual machines only existed because operating systems weren't doing their job, like partitioning and all that stuff. Well, containers are getting popular because it doesn't make sense to run 30 copies of Windows Server on a machine, because that's not necessarily useful workload. So that's what the industry is kind of realizing. I think virtual machines will still play a key role. In fact, containers can sit inside a virtual machine, right? But generally speaking, if you're just thinking about the application you're trying to run, containerization is very impactful. How fast are containers? Well, last year at Mesosphere, we demonstrated with Verizon, one of our key customers, launching 50,000 containers in 72 seconds.
Wow.
And they're all empty containers, right? They're not running, differential equations or whatever, but this gives you a sense of how fast you can launch containers and kill them. And for many of our customers, that's actually very key. So, containers. Now, microservices, why are they important? So, we talk about, shifting from building one monolithic application to moving to a world where the smallest deployable unit of the app is built out and deployed self-sufficiently by this app, as long as they maintain the API contract with the other team. Right? So it could be as small as the shopping cart function within Amazon. That might be a very small team. I think it was Jeff Bezos or somebody else that said, or it might be somebody else, 2 pizza team. If your team cannot be fed by 2 pizzas, it's too big. Right? So you want the smallest team possible that can figure out what they need to build it and maintain it. And if it fails, it's on them, not the ops guy. I mean, I'm sure that there's triaging and so forth, but ultimately these folks are responsible for this unit. It makes them very responsive and make sure they engineer availability into the application. And so you guys may have heard at Netflix, they have this thing called Chaos Monkey, which goes around just killing random servers. And the reason they do that is the application needs to be built to tolerate that. So it's expected. And you got to expect the hardware to fail, and the software has to be able to handle it by itself. It's very different from the traditional model where you have your monolithic app sitting there, and you want to make sure that, treating it like a puppet. Right? Whereas here, it's this thing's not doing well, kill it, spin it up again, and improve on it. Last piece. So we just talked about why building things in small chunks, deploying them in containers is very good, and why open source helps you not start from the ground floor. Well, data services are the equivalent of the bus inside a computer in a modern architecture, in a modern application. Right? So if you're doing an IoT service, you might have a lot of, or gen engine, a lot of information coming in to your enterprise application. You need a way to capture all that. And there are open source technologies for each of these. Right? So this one is the most popular one is called Kafka today. Analytics, this used to be Hadoop. Now increasingly it's Spark. That's the most popular. Databases, the distributed databases I'm aware of, Cassandra, very popular. And then reactive app, basically a framework for you to build applications that can react to information in real time. So some examples of that, of use cases. So those are the 4 ways in which modern apps are so impactful, right? Using open source software to move quickly, containers to launch the code easily, microservices so developers can just ship their code without having too many steps in between, and then big data services to pull it all together. Does that make sense? Okay, but what about the infrastructure? That's the app, right? And for me, this was a real eye-opening moment when I realized this. When the world moved towards distributed systems, which modern apps are, all the gains from virtualization to pull the workload disappeared. Because virtualization is great for taking a machine and cutting it up into individual VMs. And if you are Twitter and you're running a service that includes Justin Bieber, you want that VM to take up the full machine, right? But what if you need much more than that? You need to go across multiple machines. Well, that's not an abstraction that virtualization itself can manage. So what companies are doing is when they build a modern app, they might have an analytics engine, the message queue. All these pieces are distributed systems. And these are distributed systems that are open source. So they're not designed to pool with other distributed systems, right? So it's almost like you have a family of parents and kids. And all the parents make sure their kids get fed the compute resource. And if you put them all in a room, whose kids are going to get fed? I guess it depends on which parents are stronger, right? That's the problem we have, and that's why people separate them into different clusters. You might have a Spark cluster, a Cassandra cluster, you might have a CAS service, and so forth. So it's almost strange, right? We all went virtual, but when we went to the distributed systems world, we went back to physical. And that's a fundamental problem for a lot of companies that are building modern applications. And sometimes it could be 2 different versions of Spark, because one team is doing one version, another team is doing a different version. They can't share the same cluster. So you end up with these snowflake clusters that are very, very lowly utilized. I think I just said all this stuff. But I think the other piece here is difficult to experiment with new tech. So I was at a Cassandra, somebody on my team was at a Cassandra summit a couple of months ago, and we asked the room, Cassandra is the distributed database. If you guys are setting up this environment that has Spark, Cassandra, Kafka, how long did it take you guys to do that? People were saying 6 months. And these are separate clusters talking to each other. Right? And those are people who know Cassandra well. Right? I'll show you how you can do it with DCOS in about 5 minutes. In 5 minutes, I'll show you can do it in 15 seconds. Actually, I'll be more accurate. So this is the challenge. And if we think about this problem, it occurred to Ben Hyman, the co-founder of Apache Mesos. If you saw this screen on your laptop, you guys would probably be pretty upset. Right? Why should this is a stupid question to ask me? You have an operating system, go take care of it. Right? But today, when we run distributed systems, what's happening is we're doing a logical equivalent of this. Right? I have to think about which nodes to run what. And my thinking is like, when the next generation of folks that are developing computing systems, they're going to think this is silly. But this is actually what we do oftentimes today, without something that's data center scale to manage it all. So what we have to do is, instead of thinking about the app as one thing that sits on one server, which virtualization is great for, we have to think about distributed systems running on one big unified data center, logical data center, right? And how do you do this? Well, there's a joke in computer science that every problem can be solved with abstraction. And it turns out this too can be solved with abstraction. So if you have different distributed systems, right, using this technology called Apache Mesos, it's called a 2-level scheduler. It actually merges all these things into a unified distributed systems shared resource. And the only thing you have to do is take these existing distributed systems and write what's called a framework that plugs it into Mesos. And then from that point on, you can use things, run all this elastically. And it's just what we call it a data center scale operating system. Why? Because just as an operating system takes your process and assigns it to a core, and it's a file system as well, right? The data center scale operating system runs agents in each of these agents, using agents 2 different ways right now. And it manages where the distributed systems run, and also this distributed, whether it's a database or message queue, manages how that works together. And that's how you can get to a data center scale operating model, where you don't have silos based on technology. You can actually have one contiguous environment that runs all this elastic. So that's how modern apps without modern infrastructure looks like this. Modern apps with a DCOS type of operating model looks like this. And just so you guys get a sense of where this all came from, you guys may be familiar, Google and Facebook have internal proprietary hyperscale platforms that they develop internally. Apache Mesos was actually developed applying the lessons learned from these internal deployments. And then Justin Bieber, right, helped Twitter to really use Apache Mesos. All these companies, Apple, Two Sigma, Airbnb, are all companies that have been using this technology at scale. Some companies are running at 50,000 nodes plus. And most recently, earlier this year, we launched a DCOS open source project so that all of us can try this for free. All our partners can use this and build on top of it and plug into our services. So one exciting thing, I was just listening to a previous session where we talked about Lambda architecture. This is the idea that you don't need servers, you just spin things up and then you kill the infrastructure when you're done. When we open sourced this technology, there was a company called Galactic Fog that implemented this system on top of DCOS and showed it to us within a month. And so this is a very powerful way of how many different companies can plug in. And these are some of the companies. I'll just show you how things work. This is the dashboard. For those of us that like to hug servers, there's a view on nodes. But generally speaking, you're looking at services at the data center scale. And if you guys remember how long it took for some of those folks to install Spark and Kafka, this is how you install Spark on DCOS. You're done. Right? And you didn't install a container. You installed a distributed system that runs across your data center. And Kafka is another example. This is the typing will be slower than the installation, I guarantee you. So this is our data center scale operating system. These are command lines. Once you confirm you want to install it, you install it, and boom, you're done. So now all the Kafka commands are available. Kafka as a service can be used. Upgrading, also very simple. And then I mentioned earlier, there's a whole ecosystem of partners that are building on this. DCOS is the technology. I invite you to take a look. It's completely open source. And then this is how our overall product looks. The resource manager is Apache Mesos. That's what makes everything run distributed well. The plugins that allow distributed systems to run is called the service manager. And inside there is a thing called Marathon, that's the container orchestrator, as well as the frameworks that allow different data services to run. Right, I just showed you a screenshot of the universe, the app store. We have a space theme in our company, so that's all the apps that you saw. And as an operating system, of course, you have a command line interface and grab the DCOS. And for companies that need a turnkey enterprise fully supported solution, we also offer enterprise DCOS, which is basically applying role-based access control, a lot of the security features you might need, multi-tenancy features, advanced networking storage, and operational troubleshooting. So gray stuff is open source, purple stuff is our licensed software, and all this allows you to run modern applications at scale. So some examples, I'll wrap up. Esri is a geospatial analytics. By using DCOS, they're able to improve their analytics throughput by 3 orders of magnitude. So these are folks that 911 responders use to look at geospatial, where are the issues, right? Several government organizations also use them for obvious reasons. So that's Esri. Time Warner Cable use us on top of OpenStack to make sure they can deploy containers very easily to developers. And then lastly, Verizon. One of the key reasons they went with DCOS is the ability to pool the data services and containers together. Right? And I'll close with just this study that I came across from McKinsey just late last year. They did a study of the highest performing companies versus the lowest performing companies in all industries. So I think about 1,300 companies. And they looked at their software development practices. And they looked at, for the top quartile versus bottom quartile in terms of company performance, what does it look like? And it turns out the top quartile companies have developers that are 3 times more productive in terms of complexity units, and consultants will chunk them up and analyze them, right? Overall, 4 times more throughput in terms of features that they can release, and 1/5 of the defects compared to output. So, as we move to this world of modern application architectures, I expect this delta to increase even more. And the question is, are you positioned with your company to develop these services? So that's it. Thank you very much. Your time's up.